Hello everyone, I am Dr. Godan Raman. In this section, we are going to discuss with some more problem for type 1. Type 1 is nothing but in particular integral in right hand side e power ax plus by. Now I am taking one of the problem d square plus 2d dash plus d dash square into z equal to e power x plus 2y. First of all, in this equation, we just replace the auxiliary equation. So the auxiliary equation is nothing but put d equal to m, d dash equal to 1. Therefore here m square 2m plus 1 equal to 0. The product rule or quadratic form or calculator, use this to calculate this root. When the product 1 into 1, 1 plus 1, 2. Therefore I am taking m plus 1, 0. M equal to minus 1. The roots are equal. Now to find complementary function. When the roots are equal, then the complementary function is nothing but pi 1 of y plus m1 x plus x into pi 2 of y plus m2 x. m1 minus 1, so pi 1 of y minus x, x into pi 2 of y minus x cf. So this is our complementary function. And then particular integral, the particular integral type based on the right hand side value. Now to calculate particular integral, so particular integral pi equal to 1 by left hand side into right hand side from the question. In the question, left hand side value 1 divided by the function of d comma d dash into r of x comma y. This is nothing but 1 divided by left hand side d square 2d d dash square into the right hand side e power x plus 2y, e power x plus 2y. So what is the type? X plus 2y. In first type, substitute d equal to a, d dash equal to b. So what is the a value? So this is a a1 and this is a b2. Therefore a1 b2. 1 divided by 1 square, 2 into 1 into 2 plus 2 square into e power x plus 2y. Now 1 divided by 4 plus 4, 8, 9. Therefore 1 divided by 9 e power x plus 2y. This is our particular integral value. The final general solution is nothing but the general solution z equal to cf plus pi. So z equal to cf is pi 1 of y minus x plus x into pi 2 of y minus x plus 1 by 9 e power x plus 2y. So this is our problem. And then when the value, particular integral value 1 divided by the function of a comma b non-zero. Suppose the function of a comma b 0, we have used some process. Okay. Now the next problem I am going to take. Solve d square plus 6d dash plus 5d dash square z equal to e power x sin hy. But look at this problem. When I mentioned particular integral in right hand side only e power ax plus by. But here is mentioned e power x into sin hy. It's a hyperbolic formation is given. But we know that the general formation, so the general formation is nothing but sin h ax equal to e power ax minus e power minus ax divided by 2. Therefore, sin hy equal to e power y minus e power minus y by 2. We are going to apply with this particular integral. Now, as usual, the complementary function is nothing but the auxiliary equation. Put d equal to m d dash 1. Therefore, m square 6m plus 5 equal to 0. Now, the product rule, multiplication 5, addition 6. So, 1 into 5. So, m plus 1, m plus 5, 0. Multiplication 5. When I am adding this 1 plus 5, 6. Minus 1, minus 5. The roots are different and distinct. Therefore, the complementary function pi 1 of y plus m1x, pi 2 of y plus m2x, because the roots are different. Now, pi 1 of y minus x and pi 2 of y minus 5x. So, this is our complementary function. And then particular integral. Particular integral pi equal to 1 divided by, I mentioned that left hand side. So, the left hand side nothing but d square plus 6d d dash plus 5d dash square into the right hand side e power x sin hy. Now, 1 divided by d square 6d d dash 5d dash square e power x sin hy is e power y minus e power minus y by 2. When I multiply the term e power x into e power y, d square 6d d dash 5d dash square e power x into e power y minus e power x e power minus y whole divided by 2. Therefore, when the exponential power e power x, e power y, we are going to take the addition, the sum of this two x plus y value. Therefore, d square 6d d dash 5d dash square e power x plus y minus e power x minus y whole divided by 2. Whole divided by 2. Now, this is a particular integral 1, particular integral 2. So, now how to write this? 1 divided by d square 6d d dash plus 5d dash square e power x plus y by 2 minus 1 divided by d square 6d d dash 5d dash square e power x minus y by 2. For this case, as usual, put d equal to a, the a value 1, d dash equal to b, and then this is a value again 1. For here, put d equal to a 1, d dash equal to b minus 1. When I am substituting, replaced by d equal to 1 square plus 6 into 1 plus 5 into 1 square e power x plus y by 2 minus 1 divided by 1 square plus 6 into 1 minus 1 plus 5 into minus 1 square e power x minus y by 2. In this case, now this value 6 and 5 plus 1 6, 1 divided by 12 e power x plus y into 1 by 2. This is a 1 by 24 e power x plus y. And then this term, when I am doing 1 minus 6 plus 5, so 6 minus 6, 0 e power x minus y by 2. I mentioned that when it's become 0, you just move on to the previous step and multiply with, we just move on to the previous step. In the previous step, numerator multiply by x, denominator differentiate with respect to d. Therefore, minus x I multiply here, and differentiation d square differentiation 2d plus 6 into d differentiation 1 d dash, then 0 e power x minus y by 2. Now as usual, put d equal to a 1, d dash equal to b minus 1. When I am substituting this term 24 e power x plus y minus, I will take 1 by 2 here, and x by 2 into 1 plus 6 minus 1 e power x minus y. For here, this is a 2 minus 6. 2 minus 6 is minus 4. Then here plus 1 by 4, 24 e power x plus y. Then this is a minus 4, and when I multiply here 8. So plus minus 2 minus 6 minus 4, then 1 by 8 x e power x minus y. Now this is our particular integral. If I am going to take any term common, you take it, otherwise just stop up to this. So this is our particular integral. Now the general solution is nothing but general solution z equal to cf plus pi. Therefore z equal to cf is nothing but pi 1 of y plus x, pi 2 of y plus 5x, and plus 1 by 24 e power x plus y, and plus 1 by 8 x e power x minus y. So this is our final solution, type 1, when the right hand side e power ax plus by form. Thank you.